Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to all my beloved students. Today we will learn how to solve the problem related to the closed system. So this is the sample of the question. A frictionless piston cylinder device contains 8 kg of superheated water vapor at 500 kPa and 300 degrees C. Steam is now cooled at constant pressure until 70% of it by mass condensers. Determine the work done and heat transfer during this process. You need to remark some of the important keywords from the question. Firstly, piston cylinder, which represent the closed system. And then the mass, 8 kg. Superheated water vapor refer to the state of the solution, 500 kPa and 300 degrees C, the condition of the state. And steam now cooled at constant pressure. Okay, still remember constant pressure equivalent to the isobaric until 70% of it by mass condensers. So 70% is the quality or X value by mass condensers. By mass condensers, determine the work done. Okay, this is the question. So this is the second question, and heat transfer during these processes. So from the question as well, they mentioned they state also the PV diagram. So the state from 1 to 2, so this should be somewhere this arrow from 1 to 2. And also this the in the form of the diagram wise of the solid of the question. Firstly, first step, determine each state and try to sketch PV diagram. Secondly, obtain the information for each state from property table. Okay. Specific volume. This one specifically to solve the first question. And internal energy, specifically to solve the second question. Apply the work boundary equation with constant pressure to solve the first equation. So this is the equation related to the work boundary. The value B refer to the work boundary. So this is the equation. P, pressure, in bracket V2, or volume at state 2 minus volume at state 1. And then the last step, apply conservation of energy principle or first law of thermodynamics for closed system equation. So this is the equation. Q net minus the value net equal to delta U, or internal energy, plus delta KE, or kinetic energy, plus PE, delta PE, for potential energy. Step 1, determine each state and sketch PV diagram. If you notice from the equation, it already stated the superheated vapor, but we just want to cross-check the superheated vapor by referring the table. Knowing the requirement for the superheated vapor is T greater than Tsat at a given P, which is in this question 500 kPa. So that from this table, saturated water, we refer to the 500 kPa, and we managed to get this value of Tsat, which is T from the question greater than the Tsat, okay, greater than the Tsat at the P 500 kPa, which means this is the true statement for the state 1 superheated vapor. Next, we turn to the state 2. So since the question mentioned the quality or percentage is 70%, so automatically we should know the condition of the state 2 should be somewhere in mixture. because it states the quality. Bear in your mind, from the question, if you notice, they mentioned that 70%. But you need to remember the other keyword, 70% on the condensers. By the definition, the meaning of the condensers is the transformation form of phase from vapor to liquid. So that we need to get the vapor over the total mass in the mixture region. Okay, so that's why we use 0.3 instead of the 0.7, because by the logical way, 1 minus 0.7 and you can get 0.3. So this state 1, this is the state 2. Okay. Next, obtain information is state from the table, specific volume, and internal energy. By have this kind of information from the table, property table, we determine the value of V1 or specific volume, state 1, and internal energy from the table. So 500 refer to this one. Okay, then 300 I'm just referring to this one. Okay, so as simple as that. And same goes to the state 2. Just have this information by referring the saturated table, pressure table at 500 kilopascal, and then you obtain all the information and try to plug in based on the equation. V2 equal to Vf plus X or quality Vfg. Same goes to U2 equal Uf plus X2 Ufg. Okay, then you can get the V2 and U2. Next, third step, apply the work boundary equation with constant pressure to solve the first question. So this is the equation with the work boundary, which is we are using this kind of equation, 8 kilogram, 500 kilopascal, specific volume, and finally we managed to get negative 1637.6 kilojoule. This one we already complete for the question related to the work boundary. Next, apply conservation of energy principle or the first law of thermodynamics for closed system equation. So this is the equation, Q net minus W net equal to delta U plus KE plus PE. Before we go further, we need to solve the delta U. So this is the detail to solve the delta U, which is we obtain negative 12699.2 kilojoule. And then this is the complete equation set of the Q net. So we have the work out, work in, work boundary, and the internal energy, kinetic energy, and potential energy. So since from the question do not any information related to the work out, so we can cancel it out. Same goes to the work in, we can cancel it out. And then for the KE, since we know the question related to the closed system, so no any movement or related to the velocity, so we cancel this one. And same goes to the potential energy. So yet the final equation have been simplified like this. Okay, so Q net minus W equal to the delta U. So just insert all the information. This we obtained from the previous solution, and this one is this one. Okay, and then finally we managed to get negative 1436.8 kilojoule. this is the question for you guys to try at home, I mean during your free time. So just change the red in color information, which is the mass, which is 3 kilogram, and also the X, or the quality of the condense, is 30%. So also provide the final answer for the work and for the heat. Hopefully you can do this by your own and get the correct answer. So thank you. Assalamualaikum warahmatullahi taala wabarakatuh.